students, chapter 8, gravitation. Okay, yes, we have completed almost all theories of this chapter. Now we will see some questions. Example 8.2. You are given one equilateral triangle. Yes, it is one equilateral triangle. On this equilateral triangle, at each corner, masses are placed, equal masses, M. Okay, so yes, on corners of equilateral triangle, three masses are placed having same mass. Yes, and that centroid, that is G, a mass of 2m is placed. Okay, so yes, G is centroid. Your question is first, what is force acting on mass placed at G? Due to these three masses, that is first question. Second question, what is force if mass at A is double? And here if mass is double, then what is force? Okay, understand question again. Equilateral triangle, at each corner mass m, at centroid G mass 2m. You have to find what is force acting at centroid. Okay, first of all, we will assume Cartesian coordinate system. I am assuming coordinate system such that this G is at origin. If this G is at origin, it becomes positive x direction, it becomes negative x direction, it becomes positive y direction, it becomes negative y direction. Okay, the first step is, for first question, we take origin at centroid. Take origin at centroid. Take origin at centroid. So coordinate system is as shown in figure. Okay. Now simple question you have to ask. Force is acting due to mass. Yes, force is acting due to mass. Here on this point G, that is centroid, force is acting due to mass placed at A, mass placed at B, and mass placed at C. So simple. On G, force is acting due to A, B, and C. So how to write? See, force acting at G is Fg, and that Fg is equal to is Fga plus Fgd plus Fgc. Means force acting on this centroid is due to A, B, and C. Okay, so yes, it is according to superposition principle. Now, I will separately find Fga, Fgb, and Fgc. See, first of all, force acting on G due to A, Fga. Now see, vector, force is vector quantity. Vector quantity means we have to represent as magnitude and unit vector. Okay. One more thing. As it is equilateral triangle and it is centroid. Here, distance of this centroid from A, distance of this centroid from B, and distance of this centroid from C, they are equal. So here we have to assume, or it is given, okay, here AG is equal to BG is equal to CG is equal to let T is R. Yes, we have to assume, okay, let AG is equal to BG is equal to CG is equal to let T is R. Any doubt? Okay? Yes, it is given. Now, how to find force acting on G due to A? It is very simple. First of all, we will write magnitude. Magnitude, according to Newton's law, G m1 m2 upon r square. So yes, G. Here, on this centroid, what is mass? It is 2m. On A, what is mass? It is m. Okay? Okay. Divided by what is distance between A and G? A and G distances is r. So here it is r square. Hand it out. Okay. Now direction. This one is important. Gravitational force is attractive force. So see, force acting on this G due to A is attractive. Attractive means towards. Attractive means towards. So it is FGA. And see, this FGA is along positive y direction. Again, this FGA is along positive y direction. FGA is along positive y direction. And in positive y direction, what is unit vector? J direct. In positive y direction, what is unit vector? It is J direct. Simple. So see, magnitude, unit vector. Clear? Similarly, now we have to find what is force acting on G due to B. Similarly, now we have to find what is force acting on G due to B. See, here it is. Force acting on G due to B. Force acting on G due to B. FG. FG. So first of all, magnitude. G m1 m2 upon r square. So yes, it is G. Force acting on G due to B. Here mass is 2m, here mass is n. So here it is 2m n upon r square. Okay? Yes. Now direction. Force acting on G due to B. Gravitational force attractive. Attractive means towards. Force is acting on this due to this means towards, in this direction. Now in this direction, yes, this F GB. It is not x direction. It is not y direction. So it is in xy plane. But which plane? And how to write unit vector? See, it is easy. Okay, here it is. This FGB is in this direction. We know that for equilateral triangle, this whole angle becomes 60. This whole angle becomes 60 and it is half. So this angle is called 30. So this angle is also, see, it will be a Z. So this angle is also 30. And out, see, Z. Okay, so if it is 30, it is 30. So this FGD will have two components. This FGD will have two components. One in this direction, that is in negative x direction, and another is in this direction, that is in negative y direction. So this FGD has two components in negative x direction and negative y direction. Then how to write unit vector? See, as this component means angle 30, here I have to write it is minus cos 30 I get. Why minus cos 30? See, as it is making angle with this cos 30 component, it is cos 30 component. Why minus I caret? Because it is along negative x-axis. Simple. Yes, simple. So it is sin 30. It is sin 30. And as it is along negative y direction, I have to write minus sin 30. Any doubt? Any doubt? Okay, so yes, minus cos 30 and minus sin 30. And see, it is in third order. So obviously two components are negative. Clear? Any doubt? Okay. Now next, force acting on G due to C. Force acting on G due to C. FGC. FGC is equal to, now you can easily write its magnitude. Okay, sir, that is G 2m n upon r square. Okay, force acting on G due to C. On G due to C. See, that force is in this direction. It is in this direction. It is FGC. It is FGC. Yes, it is FGC. And out towards C. Okay, you to C, towards C. Okay, so yes, it is FGC. Now I will resolve this FGC into component. One in this direction and one in this direction. Okay, again we can say similarly, if this angle becomes 30, so it becomes cos 30 component. Okay, and it becomes sin 30 component. And out. Okay, this cos 30 is now towards positive x and it is towards negative. So how to write this unit vector? I can write this unit vector as cos 30i minus sin 30j minus sin 30j. Cos 30i minus sin 30j. Any doubt? So yes, we have FGA, FGB and FGC. Now how to find resultant force? Now how to find resultant force? See how to find resultant force. Okay, now force acting on G. F G. Yes, we know equation. It is FGA plus FGB plus FGC is equal to, here it is, FGA, FGB, FGC. See, in this all three equations, G 2m upon r square, G 2m upon r square, G 2m upon r square, it is common man. So yes, I will write common. G 2m upon r square. Now, in this term, what is direction? J cap. Here, minus cos 30i minus sin 30j. Next, cos 30i minus sin 30j. Any doubt? So yes, this cos 30i cut minus cos 30i cut. So this is equal to this 2g m square upon r square. Okay, yes, in bracket here it is j cap minus sin 30. Hello, sin 30 means 1 by 2. So it is 1 by 2 j cap. 1 by 2 j cap. Okay, so see, minus 1 by 2 minus 1 by 2 is minus j cap. So is equal to it is 2g m square upon r square. Here it is 0. So yes, your answer is 0. Yes, your answer is 0. Means force acting on centroid. Force acting on centroid G is 0. Yes, 0. Now, that is one question. In all cases, the force is 0. No. Here, see carefully also. First of all, it is equilateral triangle. First of all, it is equilateral triangle. Equilateral triangle. First condition. And second one. Yes, first one is equilateral triangle. And what is second one? Okay, at each corner equal masses are placed. At each corner, equal masses are placed. Clear? That's why resultant force at centroid is 0. And yes, it is true for any symmetrical objects. Yes, it is true for any symmetrical objects. If you are given one square like this, at each corner mass m and m are placed. So what is force acting on center on any mass? For example, 2m or m, whatever mass is there. Okay. Yes, at point G, Fg, force is equal to it is 0. For symmetrical objects. Clear? So yes, for any symmetrical object, you have to remember that if at each corner equal masses are placed, at corner if equal masses are placed, then at centroid total resultant gravitational force is 0. Clear? Similar question we will see in 12th, chapter 1 about electrostatics. Same question we will see in chapter 12. Clear about this question? Now there is one more question. Yes, see here it is. What is force if mass at A is doubled? This question you have to solve. Yes, this question you have to solve. It is very easy. See, if mass at A is doubled, means only this thing will change. Here G, 2m, it is mass placed at G. What is mass at A? In first case it is m. In second case, what is force mass if at mass at A is doubled? Here you have to write 2m. Here you have to write 2m. Okay. So yes, Only this thing will change. Same. In this case, if you take out G to M upon R square common, here there will be 2. Yes, here there will be 2. And 2J minus J, here it will be J only. So your answer is not 0. Yes, your answer will not be 0. Clear about this? So yes, second question is, as your homework, you have to calculate this. Okay? Clear about this? So yes, it is one question which is based on gravitational force, and yes, direction is important. Clear about this? Okay? So yes, it is an important question from this chapter. So take care about this, and yes, this is it for today.